Hi, welcome to 2.3 Polygons in Nature. Before we even get started and talk about polygons, let's really truly look at some polygons that you can find in nature. So the first thing I wanted you to look at was the way cool things that bees do to help us have honey. And that's a honeycomb. And look at this honeycomb. Stop the video here and you tell me what type of polygon you see there. Okay, next, let's look at the shell. Look at these amazing triangles that are made in this shell. And look at this pentagon here of this flower, almost a completely perfect pentagon. Isn't it just beautiful? This one to me is just so totally amazing. This is the type of a starfish. You can see all of its angles and everything. Isn't that so cool? Now, just like in this one, we see the shapes over and over again. Now, tiling is when you're connecting polygons together to make a pattern, or what we call in math a tessellation. And here are some examples of some tessellations. Now the first one that we're going to look at, it only uses one shape. Stop and tell me what shape it's using. Okay, now let's look at how it used this shape. If we look right here at the center here at this blue shape, notice we have all of the shapes around it. What's interesting to me about this is that this shape is completely covered 360 degrees by the same shape, and they simply just share a side. All right, and then the pattern continues on. And by giving it these different colors, we can actually see dimension in this, which is really interesting. Now, do you think that this same type of tessellation or pattern would work if we were using an octagon? Stop and answer and let us know. Let's go move forward here to the second example of a tessellation. Now, will you stop and write down the types of shapes that you see in this tessellation? Okay, now here are the shapes that I see. Obviously, we have some triangles here, and they're touching at their bases. We have a quadrilateral, another quadrilateral, and another quadrilateral. And if we separated a couple of these quadrilaterals, if you can look at this shape right here like this, it almost looks like a house, doesn't it? Interesting, huh? But by touching sides of a triangle with the sides of quadrilaterals. And this is a really interesting shape that they've come up with. If you look at a bigger piece of this shape, it's almost like these two triangles are in the center. And then we have, again, a ring around it of 360 degrees. And then what's really cool is if this were, we could see the whole entire thing, this then becomes a bigger one, but it's tied as if it has a link to the one next to it. So very interesting. All right, now do you think that any two polygons can be put together to create a tessellation? Now I don't want you to just say yes or no or guess. I want you to really think about it. And I want you to answer yes or no and explain why. Okay, let's look at this final tessellation. This one, as we can see here, uses triangles and hexagon. Pretty cool, huh? So we have a hexagon in the center surrounded by these triangles. Will you stop and tell me why this works? Okay, moving forward. Now, if we're looking at all of these tessellations, there's a couple generalizations that we can pull out of it. First of all, have you noticed that there's a smaller shape within the tessellation and then it kind of has a pattern that grows out from it? Now, often the smaller shape share a vertex or a center shape with the surrounding shapes. And as we talked about before, the smaller shape often is surrounded or creates a 360 degree sequence around that vertex or that center shape. Now, do you think that we might find a pattern in the sum of the interior angle measurements of the shapes used in these tessellations? Interesting, huh, to think about. Are there some complementary or supplementary angles formed by these tessellations? Possibly. Or do you think we might find a pattern in the number of sides a polygon has? So these are all things that I want you to think about while you're working on this level in Game 2. All right, you'll be asked a lot of questions having to do with what polygons can go together. But these are some questions that if you ponder these and really look at different tessellations, you should be able to find some answers to these questions. Now, do you only think regular polygons can tile? Or can we use irregular polygons to tile? Okay, now, looking at the 3 previous samples of tessellation, which one of these uses irregular polygons? And do you think you can use any irregular polygon? Stop now and answer the question. Okay, so we're going to be making a lot of tessellations. So if you like art, I have a feeling you're going to love this game as we move forward. All right, while doing your classwork, please use the shape sets and see how creative you can be in coming up with tiling some tessellations. There's a lot of questions and problems in this game having to do with that. So be creative, see what you can do. Enjoy!